Buck and boost converters transform one DC power source to another. I have used manufactured units in a couple of projects, or maybe more than a couple, but for example, I used an inexpensive buck converter to supply 5 volts from a 12-volt battery in order to power a microcontroller and GPS, in a project that was aimed at determining the direction of true north at my house. Yes, I do have a compass, and I know about magnetic declination, but what's the harm in acquiring a few thousand location fixes to either confirm or cast doubt on what we think we know? In another project, I needed to supply plate voltage to a magic eye tube, minimally around 130 volts. The converter was capable of supplying several hundred volts DC. In general, buck and boost converters are energy storage devices. A fraction of the available input energy is stored in a coil and then returned to the circuit, and with some loss of power. However, these switching power supply circuits are more efficient than voltage regulators, which waste significantly more power through heat. You will find this diagram of a buck converter, or a very similar one, all over the internet. If you didn't already know something about how the circuit functions, that single-pole switch symbol at the top left might be puzzling. The thing is, you don't just switch it on one time. You have to rock it back and forth as fast as you can, and keep doing that until your arm wears out. Alternatively, you could use one of these, a solid-state switch that can operate at high speeds without becoming fatigued. The revised schematic shows the same buck converter circuit substituting a solid-state switch in place of the single-pole switch symbol in the original. Strictly speaking, that component is just the switch, not the hand. For the hand part, you need another component. This integrated circuit chip, the 555, is more than 50 years old. Well, not this particular one, but this type of chip. To make the 555 flip the MOSFET, you need to construct a circuit like this one. PWM stands for pulse width modulation. PWM is the hand that operates the solid-state switch in a way that varies the relative durations of the on and off parts of each cycle. In the demo circuit, a multi-turn potentiometer varies pulse width from a small fraction of the cycle length to nearly its whole duration. I cannot find where I saw this simple idea. It was in one of the pages I reviewed when reading about buck and boost converters. This breadboard circuit has all the components, including the 555-based PWM, through to the boost circuit. The output ground is different from the input ground, thus the output potential is able to range between a fraction of the battery or other source voltage to many times its value. When boosting the voltage, it is important to select components such as the electrolytic capacitor that are rated for the higher anticipated output voltage. Similarly, calculate the power dissipation of the load and be sure that it is also a sufficient value. For example, at 30 volts, a 3900 ohm resistor dissipates 0.23 watts, very nearly the power dissipation rating of a quarter-watt resistor. After just a few seconds near its rated power, a test load becomes hot to the touch. A kit that I recently assembled from QRP Labs has 2 buck converter type power supplies. I'm referring to the lovely little multiband QMX transceiver. Here it is. While buck-boost converters are certainly well described on many web pages and in YouTube videos, constructing a circuit from raw components helps to solidify understanding, in my opinion. Reproducing basic concepts at the component level was a useful exercise for me.